Okay, so this is the first one of the 300 series failed engines. Well, I want to go through and show you what we found. When I got it, it was all in plastic bags, and it was all covered in oil, and it was impossible to do anything with. So I had to go through and clean everything and get it ready to show you. So this belongs to a guy that's done under 20,000 Ks. The guy that owns this has been very professional, very polite, very easy to get along with, and he's let me do this. So I really appreciate his help throughout the whole thing. So it has had three main areas of damage, so cylinder bore, cylinder bearings and top ring. So with anything like this, I go through two different ways. We go through and yes, we work out what is wrong, but we also go through and try and assess what is right to narrow the problem down, which I think is very important to approach it from two different angles. So we went through and checked things as far as cooling system efficiency, head gasket, for any signs of ineffective cooling system efficiency, head gasket, cylinder head, surface area, cylinder bores in between, that sort of thing. They have a standard multi-layer steel head gasket, no core binder as they. So then we started looking across as far as the oil side of things, as far as if you've seen some of my other videos and I talk about quantity and quality of oil, as far as the quantity of oil goes and the oil pump. The oil pump had very little sign of wear, like virtually nothing, almost brand new. I can see where the silver paste that I'll speak about has been through it, but as far as having any aggressive material go through it, that is not the case. It looked as new as you'd expect it. The normal spots of where you would find where if it had oil starvation, block pickup, lack of oil, low oil, that sort of thing, as far as cam caps, thrust bearings, all that sort of stuff where you would see starvation across all the bearings, all the mains, all the big ends, all that sort of thing is not. They're all, as far as quantity of oil that was supplied, we couldn't see any issue. Like the thrusts and that are like brand new. So we then started looking as far as heat transfer, which I've banged on a million times before about. So the issue with this, if you start with the cylinder bore, and the fact that the wear is only whether the top ring travels, it travels down the bore to the bottom of the bore where the top ring stops. The wear is all the way around the cylinder, but only on the top ring, not on the actual piston itself. So, or in between the first and second ring. I'll put some pictures up. If you have a look at the irregular pattern on the top ring, you can see where it's been rubbing. So you can see where it has picked up, and you can see material has been caught in between the first and second ring, traveled up and down with the piston. That is why the piston itself will show very little sign of wear on the skirt, but the bore is damaged from top to bottom and all the way around, because it's the ring itself that has lost its end gap. That has made heavy contact with the cylinder wall and damaged the cylinder wall as the ring traveled up and down, wearing the bore, not necessarily the piston. So that is a top ring. So what has actually happened? So we all know that the oil is squirted up into the bottom of the piston. It circulates in the piston to try and absorb as much heat as it possibly can from that piston. That then drops back into the oil, travels through the oil cooler to be cooled and recirculated throughout the engine. So much heat has built up in that piston that the heat now, the amount of heat that is calculated to travel or exit the piston through the top wall into the cylinder wall has risen past what the manufacturer allowed for as far as end gap. So the end gap when you assemble it is the gap, obviously the ring is not a full circle. So when you put it in, the ring end gap closes up. The closer you can get it, the less compression loss you'll get from ring to ring. And then I'll do a video just explaining that exactly, but so then you get less compression loss through the ring. So it's very important to have that ring as butted up as close as it possibly can without touching. In this case, because so much heat has tried to exit the piston into the cylinder wall through that top ring, it has expanded to the point where it has lost end gap. Then it is butted together, then you get friction, now you get massive temperature increase, so the ring actually expands, grabs the cylinder wall, now it's going up and down, as I say, with the piston wearing away the cylinder bore, and that is how you end up with that silver paste in the bottom of the bottom pan. So if you had like a 200 series that had been dusted, and you take like a magnetic crank angle sensor out as a pickup where the oil's been continuously pouring over the top of it, it will extract that silver paste. You pull that out, you'll get like a silver paste. That's the actual cylinder wall that ends up in the oil. So that then creates a lot of friction and drag. So we can also see as far as the main bearings go, so you have a top and bottom main bearing. So the top main bearing shell has a gallery in it, so as the oil travels out of the cylinder block, it feeds all those mains. They then circulate the oil to the mains that are into the bottom of the cradle. So with this one being that is a bottom main bearing shell, what we could see is a lot more damage, especially in the center of the actual crank, where the crank has actually dropped down. So the bottom shell is quite heavily damaged. So The bottom main bearing shells actually hold the crank like up, obviously. The oil sits between the crank and the bearing, but in this case, because the extra load created trying to push those seizing rings up the cylinder, as well as the oil now heat saturated and has gotten so thin that the crank actually drops down, sits on the bottom main bearing shells. That's how you get the bottom main bearing shell worn, but not the top main. With the conrod bearing, so this end of the crankshaft, this end of the conrod, with your conrod bearings, what you'll get, it's worse on the cylinders obviously that have, so now as the piston's trying to travel up that cylinder with the rings that have expanded and now grabbing, the extra force added by the crankshaft that's got to push harder to get that not only compression but the binding rings to go up, exhausts the oil out of the top bearing, so you end up with a lot more wear on the top conrod bearing shell and the bottom main bearing shell. So the crank drops down and runs on the bottom. The extra force applied to the conrod to push it up the bore, where's the top conrod bearing shell. So that all starts from too much heat, in this case being transferred to the top, through the top ring to the point where it lost its end gap, butted up, the extra heat and everything created, the friction, the oil, the fact that it could not absorb any more heat. You'll find the return temperature of the oil from the cooler just kept rising and rising and rising until you get to this point where it nips a ring. So I like to try and show you, because if you can see what went wrong and you can visualize it, you can see how you come to the conclusion of how we need to avoid this situation happening. So clearly not everyone's going to end up in this situation, but I don't think these people expected to end up in this situation either. So it's important to see it so you understand it. You're not just listening to someone. I've heard so much talk about oil viscosities and what to use and everything else, but I haven't heard one single person mention main bearing clearance. I haven't heard anyone mention the width of the oil ring, the tension of the oil ring, how the oil drains away from the oil ring, all that sort of stuff, whether you're in Hobart or Darwin. So there's a lot more to go through. I try and get the time to go, well, I've obviously got to do these other two, but it's trying to get the time to do all this as well. But I hope you can just sort of see and start to get a feeling from where I'm coming from as far as heat transfer, surface area, and how important all this sort of thing, especially if you're going to make modifications that will add to, or you're massively towing, you're going to add to the temperature that we create here. Please keep watching. Hopefully you'll learn something. Thank you for your time.